Welcome to the deep dive. Today, we're getting into the real mechanics of power. Basically, the math behind political loyalty and, well, betrayal.
That's right. We're trying to unpack why some leaders seem to hang on forever and what it really takes for someone new, a challenger, to actually kick them out.
And we're using selectorate theory as our guide here. It really focuses on, who matters for a leader's survival. There's the big group, the selectorate,
The pool of potential
and
supporters.
then the crucial inner circle, the
Yeah,
winning coalition, the folks whose support is absolutely non-negotiable.
exactly. And the core idea, really, is that this loyalty game, it's not about feelings. It's cold, hard calculation. Rational choices by the leader, the incumbent, and by the members of that winning coalition.
And the biggest hurdle for any challenger.
The absolute constraint is this. You must convince at least one member, just one, from the incumbent's winning team to switch sides, to defect.
No defection, no power shift. Simple as that.
In theory, yes. No defection, the incumbent stays put.
Okay, let's start with the leader already in charge, the incumbent. They need this winning coalition, let's call it W.
Mm.
They have to keep W happy, keep them paid. But the theory says it needs to be a minimal winning coalition. Why minimal? Why not bring in a few extra friends?
Well, it comes down to efficiency. Pure resource management, really. The leader wants to give the maximum possible benefit to only those people whose support they absolutely critically need.
Okay.
If you add even one extra person to W, someone you don't strictly need to win,
Yeah.
you're immediately spreading the rewards thinner. The share of the pie for everyone else, the essential people, goes down.
So you risk annoying the core group you rely on.
Precisely. So a smart incumbent keeps W just big enough to secure power and no bigger. It concentrates the benefits, makes belonging to W really valuable.
Right, like maximizing shareholder value, but for political loyalty. Okay, so let's talk about those benefits, the compensation. What are people in W actually getting?
It breaks down into two main types of goods. First, you've got public goods. Let's call them X.
Okay, X, like what? National defense, roads.
Exactly. Things everyone benefits from, whether they're in W or not. Clean air, stable currency, infrastructure, that sort of thing.
Things you can't really exclude people from easily.
Correct. Then, and this is crucial, you have private goods. We'll call these G.
Private goods, geez. So this is the targeted stuff.
This is the targeted stuff. Cash payments, access to special deals, government contracts, maybe fancy jobs, relief from taxes, things you can give selectively.
And these private goods, the G, they're divided up just among the members of W.
That's the key. The total pot of private goods, G, is split among the W members. So each person in the coalition gets a share, which is G divided by W, or GW.
So if the leader controls, say, 10 million in slush funds and W has 100 members.
Each member gets $100,000 in private benefits. Plus, they still get the public goods, X, that everyone else gets.
Okay, so their total reward in any given period is X plus GW.
That's their immediate payoff, yes. And right away, you see the incumbent's edge.
How so?
Well, the person already in power usually controls the state treasury, the resources. They typically have more G and maybe even more capacity to deliver X than a challenger who's starting from scratch.
They've got deeper pockets, basically.
Deeper pockets, yeah.
I noticed something in the research, though. Leaders often seem to lean heavily on those private goods, the GW part. Why not just focus on providing great public goods, X, for everyone? Wouldn't that be maybe cheaper or build broader support?
It might seem cheaper, but it's far less effective for locking in loyalty, especially for the essential coalition.
Why is that?
Because public goods, X, are for everyone. You get them whether you're loyal or not, whether you're in W or out. Private goods, GW, those are excludable.
So the leader can credibly threaten to cut you off from GW if you're disloyal.
Exactly. The threat of losing those private benefits, that specific, often substantial reward that only W members get, that's what really cements loyalty. If W is small, GW can be very large for each member, making them highly dependent on staying in the leader's good graces.
Okay, that makes a lot of sense. It's the targeted benefit that creates the dependency. So let's move beyond just one payday. Politics is ongoing. The theory talks about the expected benefit of staying loyal, EU loyal. It's not just X plus GW, is it? There's this multiplier involved.
Right, because the game doesn't just end after one period. We assume it's essentially an infinitely repeated game.
Infinitely repeated, meaning it just keeps going.
Well, it continues period after period until something fundamentally changes, the leader gets overthrown, or maybe they pass away. since we don't know exactly when that endpoint is.
You need a way to account for all those future potential payoffs.
Precisely. We need to calculate the total present value of that stream of future rewards.
And that's where this variable delta comes in.
Yes, delta does double duty here. It represents, first, the probability that the game continues into the next period, that the leader survives, the system holds.
Okay, probability of survival.
And second, it also acts like a standard discount factor. You know, the idea that $1 today is worth more than $1 promised next year. Future rewards are discounted back to their present value.
So delta captures both political stability and the time value of money.
Exactly.
And when you combine all that, you get this multiplier effect. The math involves summing up a series, but the result is multiplying the immediate reward, x plus GW, by this factor,
Okay.
1 divided by 1 minus delta.
That's the one. It's the present value factor for perpetuity. It essentially captures the total expected lifetime value of all the public and private goods a loyal member anticipates receiving from this leader, from right now until the leader is eventually gone.
So if delta is high, meaning people are confident the leader will stick around and they don't discount the future too much,
Then that multiplier becomes very large. Loyalty looks extremely attractive because it represents a long, valuable stream of future income. High delta means high loyalty value.
okay, I think I'm following that. The present value of staying loyal can be quite high if the leader seems stable. Now, let's flip it. Let's look at the challenger. They need to convince someone to defect. How do we calculate the expected payoff for defecting, EU defect? This is where it gets complex, right?
It does because defection introduces timing issues and, crucially, risk.
Okay, what's the first problem? The timing.
Right. Think about it. If you're a member of the VLUO, you receive your current payoff, X plus GW, from the incumbent now, in this period, period 1.
Okay, payday today.
But if you defect, and let's say the challenger wins because of your defection, when do you start getting paid by the new leader?
Presumably next period, once they're actually in charge.
Exactly. Your rewards from the challenger only begin in period 2. So that whole stream of future benefits we just talked about, it's delayed by 1 period.
So the effective multiplier changes. It's not 1 anymore.
Correct. Because the stream starts 1 period later, the present value calculation shifts. The multiplier effectively becomes delta divided by 1 minus delta, which is always smaller.
So straight off the bat, the challenger's offer is discounted more heavily just because of this payment lag.
That's the first hurdle. An immediate mathematical disadvantage for the challenger's offer.
But you said there was also risk.
Oh, yes.
Oh.
Significant risk. And this is where the size of that larger group, the selectorate, S, becomes critical. Remember S?
Yeah, the whole pool of people who could potentially be in a winning coalition.
Right. So let's say you defect. Your defection helps the challenger overthrow the incumbent. Great. But now what?
Now you hope the new leader includes you in their new winning coalition.
You hope, but there's absolutely no guarantee. Regime change is often chaotic. Think about history. Revolutions often devour their own. People who were key in the overthrow get purged later.
Like Danton in France, or Trotsky maybe. Helped win, then got sidelined, or worse.
Exactly those kinds of situations. There's a transition period, and the new leader forms their own minimal winning coalition. You, the defector, might just be discarded.
Okay, so how does the theory account for that risk of being left out in the cold?
It uses the ratio of the winning coalition size, W, to the selectorate size, S, so W divided by S, or WS.
WS, what does that represent?
It represents the probability that you, the defector, will actually be included in the new leader's stable winning coalition after the transition.
Okay, so WS is your chance of landing safely in the new inner circle.
Right. And if you are included, which happens with probability WS, you get the new payoff. We'll assume it's similar, X plus GW.
But what if you're not included?
If you're excluded, which happens with probability, WS, you lose out on all the private goods. You just get the public goods, X like everyone else outside the new coalition.
Ouch. So you're basically calculating a weighted average. The chance of getting the full reward versus the chance of getting just the basic public goods.
Precisely. You take the probability of inclusion, WS, times the full payoff, plus the probability of exclusion, 1 WS, times just the public goods payoff.
Yes. And that whole risk-adjusted expected value is then multiplied by that delayed time factor.
That gives you the total expected utility of defecting, EU defect. It incorporates both the time delay and the risk of exclusion.
Wow, okay. That WS ratio seems incredibly important then. It's not just math, it sounds like it defines the whole political system.
It absolutely does. It fundamentally shapes the leader's strategy and the system's stability. Consider an autocracy, a dictatorship.
Okay.
What does the autocrat want? Maximum control, minimum cost, maximum stability. How do they achieve it? By keeping the winning coalition, W, incredibly small, maybe just a few key generals, family members, oligarchs.
A tiny inner circle.
And they keep the selectorate S, the pool of potential replacements or coalition members, very large.
So W is tiny, S is huge, meaning WS is...
Extremely small, almost zero.
And if WS is tiny, what does that mean for potential defectors?
It means the probability of being included in the next guy's coalition is minuscule. The risk of defecting is astronomically high. You'd be betraying the current leader, who pays you a massive share of private goods, because W is small, GW is large, for a tiny chance of getting anything from the next leader.
So autocracies are stable because betrayal is just too risky. The math doesn't add up for the defector.
That's the core insight. The high risk locks in loyalty. Now contrast that with, say, a stable democracy.
Okay, how does WS look there?
In a large-scale democracy, the winning coalition, W, is effectively very large. You need roughly half the voters, maybe represented by legislators, and the selectorate, S, is basically the entire electorate.
So W and S are both large, and WS is much closer to 1, maybe like 0.5 or higher.
Much closer to 1, yes. Which means the probability of being included in the next governing coalition, even if just as a voter whose interests are represented, is relatively high. The risk of total exclusion is lower.
But what about the private goods, GW?
Because W is so large in a democracy, the amount of private goods per person, GW, is tiny. It's almost negligible. Leaders compete mainly by offering public goods, policies that benefit large swaths of the population.
So in democracies, loyalty isn't based on huge private payoffs, and the risk of defecting, like voting for the opposition, is lower.
Exactly. Which is why democratic leaders are, in theory, less personally secure and more frequently replaced. Coalition members aren't bound by massive private spoils or crippling risk. The system encourages competition based on public goods.
That's fascinating. The WS ratio really tells a story about the nature of power.
It's central to the whole framework.
Okay, so pulling it all together, we have the expected lifetime value of staying loyal, EU loyal, which uses the 1-1 multiplier.
Right.
And we have the expected lifetime value of defecting, EU defect, which uses the delayed multiplier AND factors in the WS risk.
Correct.
The theory then proposes the loyalty condition. A member of the winning coalition stays loyal if EU loyal is greater than or equal to EU defect.
That's the decision rule. Compare the two expected values.
And the punchline of the theory is?
The startling conclusion is that in a pure theoretical equilibrium where everyone is rational and informed, the leader always meets this condition. The incumbent provides just enough compensation, X plus GW, to ensure the EU loyal is always slightly better than EU defect for every member of WN.
So, the leader always survives. Defection never actually happens in theory.
In the perfect model, yes. Loyalty is always the optimal strategy for the coalition member because the leader makes it so. It predicts incredible stability.
Okay, but that clearly doesn't match reality perfectly. Leaders do get overthrown, regimes do collapse. If the math says they should survive, why don't they sometimes?
Because the model is, well, a model. It assumes perfect information, pure rationality, and crucially, it doesn't inherently account for sudden, unforeseen shocks from outside the system. Exogenous shocks.
Exogenous shocks? Like what?
Think huge economic collapses.
Yeah.
A massive natural disaster that devastates the country's resources. A sudden, debilitating illness or death of the leader. Maybe a disastrous war.
Things the model doesn't predict.
Exactly. These shocks can fundamentally break the assumptions. If the economy collapses, the incumbent might simply be unable to provide the necessary GW or even X, no matter how much they want to. The promise breaks down.
Or if the leader suddenly dies or is clearly incapacitated.
Then delta, the probability the game continues under this leader, instantly crashes towards zero. The whole foundation for the future value of loyalty, EU loyal, evaporates.
And suddenly, the challenger's risky proposition, EU defect, might look a lot better by comparison.
It becomes potentially rational. The incumbent's inability to guarantee future rewards fundamentally alters the calculation for the winning coalition members. The equilibrium breaks.
So the theory explains the underlying stability, but reality throws curveballs, economic crises, health failures, pandemics even that can knock the pieces over.
That's a good way to put it. The leader's skillful manipulation of W, S, and G provides resilience, but it's not absolute immunity to massive system-altering events.
So the final thought for someone listening. If you're in that winning coalition, the math says stick with the incumbent, if you're the challenger.
You wait for lightning to strike. You wait for that exogenous shock that weakens the incumbent's ability to deliver or shakes the coalition's faith in the future.
Which brings us back to that core idea of delta.
Absolutely. At the end of the day, maybe the most profound takeaway here is this. The stability of any regime, whether it looks like a brutal dictatorship or a stable democracy, might just hinge on one thing.
What's that?
The leader's ability to maintain that belief, that faith among the crucial winning coalition. The delta is high. The belief that the game will continue, that the rewards will keep flowing. If a leader loses command over that perception of the future,
Then the math of loyalty unravels and betrayal becomes thinkable.
betrayal becomes rational. Controlling the future, or at least the belief in the future, that's the ultimate source of power.